Hi everyone, this is Mrs. Ching. So this tutorial is to go over how to use the resources, OMIM, and the Human Genome Resources at the National Center for Biotechnology on how to use those resources for your gene expression human protein project. Okay, so basically what you're going to be doing is you're going to go to these websites to get started. Okay, so I'm going to go there right now on Safari. So here's OMIM. OMIM stands for Online Mendelian Inheritance in Man, which is a catalog of human genes and genetic diseases. So in this search box here, you can just type in your topic. So let's say I'm doing my project on sickle cell anemia. Okay, so then I type it in and I can see it'll be sorted by relevancy, and I can see it's highlighted here because that's the exact match. So then I click on it and there is some information right there for you. So the location of the gene is right here. 11 over here means the chromosome number 11. P refers to the P arm. 15.4 is the location on that arm. Okay, so if you click on that link, it'll take you to more info with genes that are next to those genes. Okay, the phenotype here is listed. There is a phenotype number, and then if you click on this AR here, it'll tell you that it's an autosomal recessive disease. Let's see. The other thing that you can click on is, come on, I'll get rid of it. Okay, the gene locus here is what we're looking at. HBB actually stands for hemoglobin beta chain. And how would you know that? Because if you click on this guy, there's a blue link. You can open it up on a new tab, and it will then tell you that HBB is human beta locus. It's also abbreviated as HBB. So there's a lot more information about the gene over here on that entry. Okay, let's go back to this main page. So again, here there's a lot more information that you may have to sift through to get to answer all those questions. The other thing I want to tell you is, I can't get rid of that. Click on this external link section and then expand to protein. So when you go to UnitProt, it will give you an entry on the protein. Okay, so here's the hemoglobin subunit beta in humans, and then it tells you here that there's a lot of information like binding site and all that. But what you want to do is actually go all the way down to, okay, a couple of things. If you're looking to answer what happens where the mutation occurs, there's this information right here under sickle cell anemia. I mean, it's going to vary for each of you, right? So if you're having trouble finding it, let me know. The other thing I want to show you is that you can see that there is the 3D structure here that you can spin around, zoom in, zoom out as you need. Okay. The other info that you're going to need is the size of the protein, right? So there is a size of the protein right here where it says length, 147. That means 147 amino acids. And remember how we can have one-letter abbreviations for your amino acids. So M is methionine, V is for valine, etc., right? So there's your sequence. Okay, so that's the protein. What happens if you need to find the information on the gene itself? Okay, so on the gene, you're going to go back to this guy, and then I think it was this one. gene structure. Let's go all the way down. Gene structure, mapping. No, that's not it. Okay. So there was, shoot, where did it go? Sorry. Oh, that's right. The gene structure, the information on the gene itself, you'll find it on a second site, which is at the National Center for Biotech Information. Okay, so here I'm going to type in the name of the gene, which is hemoglobin beta. Okay, so when I type that in, I'm going to click on this, which is my first match, right? Chromosome 11, to double check that you're on the same page. Then down here, let's see. So it tells me that it is in a Homo sapien. There's the location, there's exon counts, and then there's actually a map of what it looks like, but that's like way too much info from what you guys need. So what you actually need to do is go to it's down here somewhere. Here, so I'm going to click on this one, so one of the codes, and then it'll pull up that is a sequence of the DNA of that gene. And it also tells me that this is the size of the gene, which is 438 base pairs. It's linear, it's a DNA, it's in Homo sapiens, and so that will help you answer number 1, A, and B. Okay, so again, play around with the website, and you're definitely going to have to cite these sources. So if you're having trouble, let me know. Yeah, and I hope that helps.